Hi, in this video I'm going to discuss lambda expressions. Lambda expressions are a cool new feature added in Java 8. It's like an anonymous function. So it has everything a function does without a name. So it has parameters, it has body, and it has return value, but it does not have any name. It's actually a shorthand to write and use functions in the same place, so you don't have to declare it elsewhere. You just write and use it in the same place. It helps a lot by reducing the volume of code, by removing syntactic boilerplate code, which I will illustrate with an example later. It can also replace verbose anonymous inner classes. It brings functional programming to Java, which Java, as we all know, is a highly object-oriented language. But here with lambdas, we can focus on function and functional programming. But everything in Java is an object, so are lambda expressions. It's an object of type functional interface, which also I will explain later. So here I have a simple example of a lambda. So this is a lambda expression, and so it's a function. It has these two parameters, string 1 and string 2. They are the two parameters of this lambda expression. This is the lambda keyword, and then here we have the actual function body. And what it's doing here is it's simply comparing the two strings s1 and s2 which are passed to this methods. So it compares the two strings and returns the result. Now the syntax, it can be even can get even simpler. So we could just have, we can get rid of the parameter type and can simply have s1 comma s2, because the compiler may already know about the parameter type, and also because this is a single line function, so we can get rid of the parentheses and also the return keyword, and it becomes as simple as this. So this is an anonymous function which takes in two parameters, s1 and s2, and it compares the two and returns back the result. This is another very simple example of a lambda. So in this case, the lambda expression, the anonymous function, it's actually not taking in, there is no parameter, and all it does is it's going to return hello. So that's a very simple example of a lambda expression. Now let's go back to Eclipse so that we can run some tests and also look at things in little more detail. So here I have a test method where what I'm trying to do is I have a list of string. So names is a list of string, and it has all these strings in the list, and then I need to sort my list of strings. So in the pre-lambda days in Java, the way we will do it is we will need to implement the comparator interface. So what we will do is we would create a anonymous inner class like this, which implements the comparator interface. And so here it's implementing the compare method in the comparator interface. And in the compare method, what we do is we get two strings, and then we compare it and return the result back. And then we would use the collections sort method. We will pass the list and also an instance of the comparator, and then I'm just printing the list of string. So this is, as you can see, with anonymous inner classes, the volume of code is quite a bit for doing a simple compare. Now this can be replaced with a lambda expression. So here is my lambda expression, which replaces the implementation of the comparator interface. So here I have two parameters, S1 and S2 for this lambda, and in the implementation I do the same thing. I compare and return it back. And as I was explaining earlier, the volume of code can be even less by doing something like this. So I have the two parameters. I don't need to specify the parameter type. So there are two parameters, S1 and S2, and I just compare the two strings and return it back. So as you can see, the volume of code can be significantly reduced using lambdas instead of this anonymous inner class over here. So let's quickly run this test. So I'm going to run test 1. So as you can see, it sorted my strings. So I have B, C, T, X, and Z. So it sorted my strings in the ascending order. So this was done by the anonymous inner class, and then here this was done by the lambda expression, which I have here. Another example I have here is in this test2 method. So here I'm trying to create a new thread class, and for that I need to pass an instance of the runnable interface. So what I do here is I create this anonymous inner class which implements the runnable interface. So here is the implementation of the run method in the runnable interface, where I simply print that this is an hello using anonymous inner class. So again, this anonymous inner class code can be replaced with a lambda. So this is the lambda which can replace this anonymous inner class implementing the runnable interface. So this lambda here is doing that. It's implementing the runnable interface. So because the run method which it has to implement has no parameters, so the same way this lambda it's not taking any parameter, and it's simply printing hello in the run method. Of course it says hello using lambda expression. So when we run this is going to print this hello using lambda expression, whereas this one is going to print hello using anonymous inner class. So let's go ahead and run the test 2. So as expected, the first thread printed hello using anonymous inner class, and the second thread printed hello using lambda expression. So just to explain a little bit more, what's happening here is this lambda is actually implementing the runnable interface here. So as I said, lambdas are objects of type functional interface. In this case, runnable is the functional interface, and it has this run method which was implemented by this lambda, and that's why it's not taking any parameter. And this is the implementation of the run method, where it simply prints hello. In the previous example that we did, so this lambda over here, this is actually implementing the comparator interface. So it's implementing the compare method in the comparator interface. And because the compare method has two parameters, so the same way this lambda is taking two parameters, s1 and s2, and this is just the implementation of the method. So it's comparing the two parameters and returning it back. So here in this video, this was an introduction to lambdas. We learned that lambdas are anonymous functions. They help in reducing a lot of the boilerplate code, and it brings functional programming to Java. And also lambdas are objects of type functional interface. Thanks for watching this video.